Hello there, Gregory Carlson here for College Algebra, and welcome to Chapter 3. You'll remember that on page 25 of the notes, I introduced all of the parent functions of some of the most useful and most common parent functions, and now we're going to start to look at them. One at a time and really understand more about them. And the one we're going to start with are quadratics, which is where we have an x squared term, and that is our highest degree. In other words, we don't have any x with a higher exponent other than 2. There's two ways to write the formula for a quadratic. The first is like this, which is called vertex form, and the second is like this, which is called standard form. So we're going to look at an example of both of them. The reason this is vertex form is because it's really easy to see where the vertex is. So you can see right here, there's an x component and a y component. And so the vertex is going to be, you flip the sign of this, and you keep the sign of that. So the vertex is -3, -1. So what is a vertex, you might be asking? The vertex is the minimum point on our parabola. It's the point where it starts to turn back on itself. If our parabola is opening down, then the vertex is the maximum point on the parabola. So in looking at this parabola, we see that the vertex is -3, -1, as we came up with from the equation. And so what is the domain and what is the range? Well, the domain, we don't see any absolute value, we don't see any square roots, so the domain is actually going to be just all real numbers. We have something for all of x. So it's -∞ to infinity. The range, however, you notice that this graph turns and there's nothing down here. The range is there's only y values, output values, for above a certain value. What value, you might ask? The y component of the vertex. We're only going to have range values bigger than the y component of the vertex. And so that's going to be, remember that point was -1, so the range would be brackets -1 to infinity. Because we're going to have graph, there exists graph for everywhere above -1. So remember, when we're talking domain, we're talking x, range, we're talking y. There's also something called the axis of symmetry. And the axis of symmetry, you'll remember that if we have a parabola that's on the origin, it's even because both sides match each other. Well, for every vertex, there will be an axis of symmetry where the graph is a mirror image of itself on both sides of the axis of symmetry. And so because that's a vertical line in this case, this is going to be an equation of a line. And since it's a vertical line, the equation is going to be x equals -3. That's the equation of this line right here. And you'll notice, by the way, that -3 is the x component of our vertex. And that's always going to be the case. So the range is going to be, this y, regarding this y value on the vertex, and the axis of symmetry is going to be using the x value. Let's find the y-intercept and the x-intercepts. Finding the y-intercept of a graph is always very easy. All you have to do is plug in 0 for x everywhere you see an x and see what number that is. So let's plug in 0 for x. We get f of 0. The y-intercept is basically f of 0. What do you get when you plug in 0? Where are we on the y-axis? So that'll be 0 plus 3, quantity squared minus 1, which will equal 0 plus 3 is 3, 3 squared is 9, 9 minus 1 is 8. So that means the y-intercept is going to be the point 0, 8. The y-intercept is when x is 0. The x-intercept is when y is 0. That's a little confusing, but just remember that it's always backwards like that. The y-intercept is when x is 0. The x-intercepts are when y is 0. And you notice we hit the y-axis right there at the point 0, 8. Excuse me. Let's find the x-intercepts. That's a little bit trickier to do, to find the x-intercepts. Basically what you have to do is you have to factor this. You have to FOIL this out, subtract 1, and then factor it to find the x-intercepts. We're not going to need to do that, though, because I see my x-intercepts are here and here. It's on the graph where the graph crosses the x-axis, or the x-intercepts, when y is 0. So we see that those 2 points are -4 and -2. So it's going to be -4, 0 is 1. X-intercept, that's just a semicolon to separate them. and the second is negative 2 comma 0. So those are the x-intercepts. So that's how you would find all of the information for that. What is the largest open interval for where the graph is increasing? So we're asking a when question, so we're looking at x. It looks like we're increasing once we hit the vertex and everything beyond that. So remember, we're talking about x, so we're increasing from negative 3 to infinity. Where are we decreasing? Well, we're decreasing until we hit the vertex. And so we're decreasing from negative infinity to negative 3. And remember, we are looking at x values when we do this. Okie dokie, so that's how you would find all of this information. By the way, at the vertex, technically speaking, at that one instantaneous point, the graph is flat, and so it has a slope of 0 right there. Okay, let's look at doing all of that with a parabola that's in standard form. Here's how you find the vertex when it's in standard form like this. First off, this coefficient we're going to call a. So in this case, a is 1, b is this number, c is this number. So in this case, a is 1, b is negative 4, and c is 6. And there's a magic way to get the vertex. For the vertex, the x part of the vertex is negative b divided by 2a. That's just what it's going to be. You can't just see it as easily as right here. You're actually going to have to do some math. And you might be wondering, where did this negative b over 2a come from? And the truth is, you're not going to see where this comes from until calculus, but there is a reason why it's negative b over 2a. So that's the x part, so b is negative 4, so that's going to be negative 4 divided by 2 times a. So negative 4, because of the negative sign here, divided by 2 times 1, because a was 1. So those two negatives become a positive. So that means that the x part of the vertex is 2, because 4 divided by 2. That's how you find the x part of the vertex. The way you find the y part of the vertex is you just take this number and plug it in and find out what y is equal to. So 2 squared is 4, minus 4 times 2 is minus 8, plus 6. So 4 minus 8 is negative 4, plus 6 is 2. So in this case, we got kind of lucky. Our vertex is going to be the point 2 comma 2, right there. That won't always be the case. So you need to memorize this. Negative b over 2a is always the case. Figure out what that is, plug that in to find the y part. Now, because this value is just 1 here in front of the x squared, our vertex will open up because it's positive, and it always opens up in the same way. You go over 1, up 1 in both directions from the vertex. Then you go over 2, up 4, and it's always in that order. Then you go over 3, up 9. Over 3 from the vertex, up 9. And so you notice we went up 1, up 4, up 9, then it would be 16, 25, 36, and you should recognize that these are square numbers. And that should make sense because we're doing a square function, a quadratic. So there's your happy little parabola right there. So that's the process for graphing this. Find the vertex, and then as long as this is a positive 1 right here, it's over 1, up 1, over 2, up 4, over 3, up 9, and so on. If a is a different number than 1, you just multiply this sequence times whatever number is there. And we'll look at an example of that later. Okay, so we know that our vertex, I'll write it over here because I'm out of room, the vertex was the point 2, 2. And so the axis of symmetry is going to be a line that comes through my parabola like this. And that's going to be the line x equals the positive, well, x equals the x value, so x equals 2 is the axis of symmetry. Domain, we can plug in any point, so the domain is all real numbers. The range, we're looking at the y values. We see that there is a minimum on our graph, and that minimum value is 2. So the range is only from 2 onwards. It looks like we're increasing, starting at the vertex going up. So from 2 to infinity, we're increasing. And from negative infinity to negative 2, we're decreasing. And at that point, at the vertex, at 2, we're actually having a slope of 0 at that one instantaneous point. That's how you find all the information for one in vertex form and one in standard form. Remember the vertex for this, you flip this sign, but keep that sign to make the vertex -3, -1. For the vertex for here, you do x equals -b over 2a, figure out what that number is, and then just plug it in to find the y part. I will see you in part 2 for the rest of 3.1.